I'm Seth, the founder of Sutro. The title of the talk is Horizontal Predictable High-Throughput Inference for Synthetic Data Generation, Evals, and More. It's a bit of a mouthful. Our talk could have easily been called The Hard Things We've Learned About Building a Batch Inference Service. My hope is that it's going to serve as a helpful resource to any of the folks in this room who are attempting similar. So a little bit about Sutro. We got started a little over a year ago. We're building something akin to OLAP for AI. So practically speaking, the core of this product is a high throughput distributed batch inference service, essentially map and map reduce for with LLM inference as the core compute primitive. People use us for synthetic data generation, large scale evals, often in a tight loop for post-training infra. As well as unstructured data analytics, tasks like structured extraction, classification, and open set labeling. We think batch inference is a really important workload, and it's going to enable massive productivity and research gains in the coming years. Something customers love to ask us in an initial conversation is something along the lines of this question: isn't batch inference easy? The answer is yes and no. Yes, it's easy to create a basic batch inference service. And no, it's very hard to create one that's fast, efficient, and one that your engineers will actually appreciate. So when you start working on a batch inference service, there are a slew of technical considerations and decisions you'll have to make. I think the most important ones are basically listed out on this slide. So the first one being managing data and compute. Notice I'm not saying actually choice of clouds. We think that cloud resources are pretty fungible at this point, and GPU availability is not really a scarcity anymore. It's sort of in abundance, especially spot hardware, which is great for batch inference in particular. So what is hard is essentially selecting and managing a distributed compute framework. The lovely hosts of this conference are certainly a great option, but I'm not here to sort of plug any one framework in particular. So the things that you really need to manage are be able to manage our multiple clouds, multiple accelerator types, dealing with things like spot markets and object storage. You'll also want to account for things like fault tolerance that are common in distributed systems. So things like network outages, system congestion, et cetera. On selecting an inference framework itself, we're not really going to go into specifics about which inference frameworks are the best. There's a lot of debates out there, and there are a lot of great options. Each have their pros and cons. But depending on which inference framework you choose, there's a lot to consider sort of around memory and performance quirks, cold start times, version changes, as many of these projects are still quite early and changing often. You'll also have to manage some version of a model repository yourself. You don't probably want to be pulling from Hugging Face every time, and there's a lot to do in terms of mitigating overhead associated with weight transfer and storage. I'll get to this next, but depending on what you're building and who you're building it for, it may be necessary to build out harnesses to profile performance, quality, and cost. So figuring out things like actual throughput, model sizes, quantization, average workload shapes, these can all be a significant challenge. And there's a lot of room for improvement typically in GPU overhead itself. So the extent to which you can actually mitigate overhead sort of determines how much yield you can actually get from the compute resources alongside throughput itself. So I think what's actually more interesting here than the technical decisions are sort of the operational ones. It basically asks the question, am I building a service that empowers or restricts the capability of engineers and stakeholders using it? You're hopefully building a system for humans in some capacity. It really depends on what the persona is, but there's a lot to think about here if it's not just some service that runs in the background. So for example, if you're building the service with researchers in mind, you probably need to design heavily around high experimental velocity, useful metadata, and collaboration. If you're building for enterprise-oriented tasks, you probably need to create great human-in-the-loop interfaces for less technical users and potentially data labelers. If you're building for critical services, you'll need to find ways to maintain tight SLAs while preserving the cost-saving nature of the system. It's probably part of the reason you're building a batch inference system in the first place. So now I'll get into just a few of the specific hard things we've encountered building Sutro that you may be likely to encounter yourselves. We don't really have the time to go into depth about how we solved all of these things, but I'm more than happy to be a resource to anyone in the room who wants to go into more depth afterwards or contact me via email or otherwise. But I'll talk about what the problems are. So the first thing is throughput profiling. This may not actually seem that important. Like you can just kind of put your model on a machine and get it to run as fast as you can get. But it's actually very critical if you want predictable SLAs. And again, like I said earlier, this may or may not be important depending on who you're building for. It's also pretty important to have throughput profiling to correctly tune an inference framework against your predicted workload needs. So you actually need to see, based on the input and output token shapes of what you're generally sending in, if you've actually tuned the inference framework appropriately. So in case you weren't aware, throughput is highly nonlinear. Some of the factors it depends on are model size, hardware and parallelism type, as well as the workload shape, like I mentioned. It is a somewhat reasonable assumption to fix the model size and hardware variables. It's possible you'd be running a few models on only H100s or something like that. But the system is probably likely to see workloads of various shapes and sizes. The chart here on the right is theoretical, but it basically points to attention math, and that for a given workload shape, throughput can vary greatly. So if you have very short sequences, input sequences, and very long output sequences, this can be pretty common with synthetic data generation workloads and pretty common with reasoning workloads. You have very different throughput performance. If you have sort of very prefill heavy workloads and very short output sequences, this is often like unstructured data processing or classification tasks, the throughput looks very different. So if you're sending both in, it's pretty important to actually be able to account for that average workload shape. It's also very important if you're trying to account and ascribe costs to what you're doing on a per token basis. You need to basically have a way to map backwards. Yeah, and so to the extent that you can basically accurately profile this and anticipate workload compute demands enables you to accurately control completion time. So in other words, doing this kind of work allows you to figure out how much parallelization is actually needed to get jobs completed within a given SLA. Hard thing number 2, I would say, is data and compute manage, which I spoke a little bit about earlier. There's a bunch of things to account for when building a distributed system. Hopefully the framework that you choose handles many of the machine and networking failures relatively gracefully. I would also recommend introducing checkpointing to external storage to make sure you're saving progress as it's running to avoid duplicitous work in the event of machine or networking failure. You don't want these giant batch inference runs to basically fail part of the way through, or one worker fails and it kills the whole job. This can be many thousands of dollars at a time. So there are a lot of quirks around doing multi-cloud work. I assume a lot of the folks in the room are using multi-cloud to some extent, and not every cloud is created identical. Frameworks like SkyPilot are great. They do a really good job of making the cloud more fungible and hence increasing the availability of compute resources. I know they have a booth here, so I'm sure they'd be happy to tell you all about it, and we can tell you how we use them today. Finally, there are a lot of these considerations here around data and model weight egress, since you're likely to be running workers in global cloud regions for maximum availability. We run spot jobs all over the world. And options like R2 are great for zero egress via storage, but they come with their own latency constraints. Essentially, if we have to transfer something like a terabyte of weights to a bunch of workers around the world, that comes with a lot of its own bottlenecks. So finally getting it back to some of the operational considerations. I would consider making your batch inference service as enjoyable as a product as possible to be hard thing number 3. For one thing, batch inference workloads are non-deterministic, sort of unlike past data processing workloads of the last couple of decades. So we think metadata and being able to track experiments is more important than ever, and it's really important to stakeholders. So you should really treat it like a first-class citizen. You should basically tightly couple storage and metadata, according to what your users need. Batch inference jobs are also need to be interoperable. So it's likely that this does come in some stage of a pipeline, and there needs to be pre and post processing steps associated with it. So you're also likely to encounter these kind of compound workloads, which means that outputs from one job immediately feed into the next. And as mentioned before, you need to keep harping on this, but you need to build a service that humans actually enjoy using, which means making it fast, collaborative, and lets them get their job done. I have this dumb picture of this DIY truck on the right here as a reminder that just because something gets the basic job done doesn't mean that it will be a joy to use or that it will be a good build versus buy decision at all. So on that note, I get to plug our thing. I'm not actually going to, but in all seriousness, I suspect most folks in this room are the build versus buy type. So I wouldn't necessarily expect you to use Sutro, at least today, versus your home rolling your own solution. That said, we've put a ton of effort into creating what we believe is the best managed batch inference product out there today, and we'd love to have you come try it, even if it's just a benchmark against your own internal service. So yeah, as mentioned, I'd love to be a resource to anyone in the here who wants it. Please feel free to contact me, talk to me after the talk. We're also hiring. Thanks again for your attention, and have a great rest of Ray Summit. Thanks. I don't know if there's time for questions or if it also seems like 4 minutes.
We actually do have time for questions. The next talk is not for 30 minutes, if anyone does have any. For Seth? Oh, one question here.
You mentioned the importance of metadata. What kind of metadata are you capturing for your jobs that you found to be the most helpful?
Sorry, I couldn't actually hear it.
Can you hear me better now? Okay, sorry. You mentioned the importance of metadata and capturing it. I was wondering what metadata you were capturing that you found the most helpful.
Yeah, so I think the most useful metadata is things that you can tie back to like specific experiments, right? So if you're running like synthetic data generation and eval jobs in particular, like you want those jobs to actually be tracked in some kind of like stateful system. There aren't really like great places to do that in general right now. We find like a lot of people just pushing stuff back into Hugging Face and giving it some name. But I think actually coupling like the workload and stored inputs and outputs alongside things like just names, job descriptions, and like tags that you can assign it and like create some kind of search system over it later. It tends to be extremely useful for researchers and being able to carry out their experiments. So I would just say like even just the basic things like that are critical, and you may only like discover later.
You mentioned about checkpointing the inferences. What type of model would require like inferences to be checkpointed, and what would you be checkpointing in that case?
Sure. So like if you're doing like a distributed batch inference service, like maybe you're trying to run 50,000 inferences per worker or something like that, and maybe you're running on a big model, it'll take an hour or two to run. So like basically checkpointing outputs along the way. So if you get 95% of the way there and then your worker gets preempted, you're going to have lost all the work unless you basically write out to external storage as you're going. It's basically just that.
One more question down here for Seth.
Hi, do you use any like RAID data framework for parallelizing the I/O and so on, like also pre-processing?
Yeah, so it's a good question. We don't have a lot of like pre-processing, like managed pre-processing stuff built into the system right now. But yeah, like it's a great question. We're pretty keenly aware in that like being necessary for a lot of folks, but we kind of treat that as like an independent service right now. So if someone wants to do distributed pre and post processing, it's better done on a service that's not ours, at least today.
Any more questions for Seth? One more?
Hey Seth, nice to meet you this year as well. I just want to check, what kind of input do you need for your synthetic data?
Sorry, the question was what kind of...
What kind of input you need for triggering the synthetic data generation?
Yeah, so synthetic data generation has like a bunch of its own like methodologies. There's a lot of statistical work that goes into basically creating useful synthetic data. We actually have some guides on the website about how to do that. Our thing right now is more of like a managed infrastructure service that just like does the inference, really efficiently more than handles a lot of like the statistical methodologies. But we're actually baking more and more of that into the product as kind of managed offerings over time. So yeah, I can feel free to shoot you the guides or just look on our documentation.
what kind of a synthetic data could you use to create?
What kind of synthetic data can you create is the question?
Uh-huh.
So basically anything that an LLM can generate, people actually use the word synthetic data generation in a bunch of different ways today. A lot of times people just mean offline generations. So if you're like retroactively testing or like actually just offline testing a model before you deploy it, you like run it over some large corpus of data. Some people consider that to be synthetic data generation. There's also a lot of like privacy preserving workloads. There's a lot of like task and world knowledge specific synthetic data to create from larger models that allow you to distill into smaller models. We see a lot of that sort of among users.
One more question about
Sure.
synthetic data generation. Are you primarily focusing on like text modality, or are you also generating images, like synthetic images for like training data?
Yeah, right now we're focused on just text, but we definitely have plans to expand to like all multimodal in the not too distant future.
How about task-related agentic data?
Agentic stuff.
Uh-huh.
Yeah, I mean, there's a bunch of different ways to answer that. I don't really consider us to be like an agent framework kind of thing, but like large scale offline evals are like one thing that would certainly like you probably, if you're developing an agentic system, you need to do large scale evals. Our system will be pretty good at that. We're also probably going to introduce some other abstractions that are more of like a flex processing queue, like a high throughput request queue that would work well for like sort of singleton or like event-driven agent architectures over time. But yeah, generally people who we talk to who are like doing agent stuff today, it's like our thing's probably not like the right like inference choice today. You want something that's like lower latency, a bit faster.